Okay, Lexi, here's number 23 from lesson 40. You know how much I don't love these proofs, but we're going to try to work through this one. I actually, when I sat down to do it on my own, found one method, and then I checked it with the answer key, and there's a slightly different step that they take than I did, so I'm going to stick to the one that is in the answer key because that is most likely the steps you're going to be looking for when you're looking on your computer for the correct answers. So let's take a look at what we have here. So this is a little bit of a complex shape here. Let's look at our given and mark up what we have. Okay, so in our given information up here, we see that BE is parallel to CD. So BE is parallel to CD. Oops, this is supposed to be a D over here. I got cut off. And what else? BE is also congruent to CD, so we'll go ahead and mark those with a little tick mark like that. And then AE is congruent to ED. AE is congruent to ED. Okay, and what we're trying to prove is that AB is parallel to CE. So let's just mark those. So AB is parallel to CE. That's what we're trying to prove, okay? So what this tells me, first of all, I've got two pairs of parallel lines, one that's given to us and one that we're trying to prove to be true. So that tells me when I think about parallel lines, then I'm thinking about a transversal. I'm thinking about what a transversal does. A transversal creates angle pairs and relationships between those. Remember, sometimes we see alternate interior angles, and sometimes we see corresponding angles, which are congruent. Sometimes we see supplementary angles. So let's see what we do see based on what has been given. So we're going to focus on, and I'm going to take the highlighter in a different color here so that we can focus on those. So let me highlight in yellow these parallel lines here, because I want us to focus on what they're creating. And of course, the pink line here is a transversal, but there's also another transversal cutting through. So when I did the proof before I checked in the answer key, I used this line here as the transversal, and I found alternate interior angles to be congruent. And it worked me through to an appropriate, correct proof. However, the author is helping us to see another transversal line coming through here, so we're going to follow that. Now, it's a little harder, in my opinion. It's a little harder to see, so I'm going to pull off the paper here right below this, and I'm just going to write what I'm pulling off here so you can follow me. Okay, so I just pulled off those highlighted in yellow parallel lines, and I wrote them down below. And this is what he's using as the transversal. Okay, so it's actually, let me put this in yellow also. It's actually this line right here he's using as the transversal. So that's the line that's cutting through the two parallel lines. Okay, and so what that creates for us here is corresponding angles. So remember, if it's sitting on the same position on top of or below or however, on those parallel lines, so here these lines are our parallel lines, if those angles are positioned the exact same way on each parallel line, then they are congruent. So what that tells us then is this angle and this angle are corresponding angles and are congruent. Okay, so that's going to be something we're going to write in our proof over here. So let's go ahead and fill in. I was a bit remiss here. Let's go ahead and fill in our given information. So the first step is going to be just writing exactly what's been given, and that was that BE was parallel to CD. Also that BE is congruent to CD. And there was a third piece of given information, and that is that AE is congruent to ED. Okay, and that is simply given information. Okay, number two is what we just proved. We just proved that these two angles down here are congruent to each other. So let's list what those are. I'm going to give you a minute to look at it and see how you want to list those. This angle right here and this angle right here. Is going to be angle BEA is congruent to angle CDE. And why is that? Simply because parallel lines that have a transversal cutting through creates corresponding angles that are congruent. So how do we want to write this? Let's just say it like this. So this is what you should probably see in your choices. So if two parallel lines are cut by a transversal, then their corresponding angles, I'm going to just abbreviate that and put my little symbol here, are congruent. Okay? Two parallel lines are cut by a transversal, then their corresponding angles are congruent. Number 3, let's see what we need to look for next. Now, I notice that I have my two triangles here, and I notice that there are, I'm going to kind of highlight these in yet a different color so you can follow me here. Let's do orange. Okay, so I have a side. Oh, that looks yellow. Let's pick something different. Let's take, I guess we'll try orange. That was orange. Let's try green. That looks like yellow too. Oh, well, it is what it is. So I'll circle them instead, and I'll use pink. Here we go. All right, so I have two sides equal to each other. I have two more sides that are equal to each other, and I have an angle in each triangle that are equal to each other. So what does that tell us? That's 3 corresponding parts, and there's a shortcut here that we can call this. We have a side, we have an angle, and we have a side. So based on that, we've just proven that our two triangles are also congruent. So let's go ahead and list that. So triangle ABE is congruent to triangle ECD. And why is that? Because of side, angle, side. Remember, we can just use the shortcut name. Once we've proven it and we can see it, we can just list the shortcut name there. Number 4. Okay, so what am I trying to find here? We're trying to prove that AB and CE that I've highlighted in pink over there are actually parallel. Well, do I have enough to show that they are? Well, not yet. But think about this with me, and I'm going to erase some of this out of here because it's getting a little bit messy. Okay? If we're looking to show that these lines are parallel, and we had this angle and this angle were congruent, right? Let me see here. Yeah, but we don't really need that. Okay, so we don't need those marked there. But based on those lines, you keep in mind that those triangles are also congruent. So we know all their corresponding parts are going to be congruent. What can I use to determine, how can I use those lines that we're trying to prove parallel? Would there be any other corresponding parts that I could mark congruent? Well, actually, yes, there are. So notice this. So remember, our triangles are congruent. So that means that angle A and angle CED would also be congruent. Why do I care about those two angles? Why did I pick those? Well, because just like he used that line on the bottom for the transversal, the same is true here. So look, this is the transversal line cutting through these two lines. And notice how they're positioned. Let me pull those off the grid here so you can see them. If you have these parallel lines and you have this transversal cutting through, and I tell you they're parallel, and you see that this angle and this angle are congruent, then we have another pair of corresponding angles. And corresponding angles are congruent. Okay? However, I can't say they're corresponding angles just yet, right? I marked those congruent, these angles. I marked them congruent because I know that these two triangles are congruent. So all corresponding angles and sides are congruent. So the first thing we want to do is go ahead and mark that angle A is congruent to angle CED. And how do we know that? Because the triangles are congruent, so all corresponding parts are congruent. So corresponding parts of congruent triangles are congruent. That's step 4. We have to put that in there because once you've shown that those angles are congruent, now we can look at this, now we can look at this diagram that I drew here to show how that fits into parallel lines. So if they're congruent, then that means these have to be parallel lines because they are also showing that they're corresponding angles. So now we can say AB is parallel to CE, and that is what we tried all those steps. We had to work down those steps to prove that statement to be true. So how do I write my reason here? Well, we're going to say if two lines form congruent, corresponding angles with a transversal. And this would be in that one little packet I gave you too, and you could find this when you're looking under the parallel lines. This is like the converse of the original definition or theorem. Then the lines are also parallel. Okay, that is the proof for number 23. Hopefully that made some sense. These proofs can be hard to work down, but those are the steps that you will need to work through this proof. I hope this is helpful, Lexi, and I will continue to work through these and see if I can get some of those texted over to you. Okay, honey, have a good night. Talk to you later.